Let's have a look at the next question. Figure 4.1 shows the apparatus that could be used to measure the specific latent heat of ice. Here we have a 60-watt heater in which, in other words, its power rating is given as 60 watt. Now we have melting ice at 0 degrees Celsius, which means energy supplied will go to a change of state and not to a change of temperature. Describe how you would use the apparatus. You may assume that ice is at 0 degrees Celsius and a stopwatch is available. State all the readings that would be needed at each state. So we first start by turning on the power supply, thereby making sure the heater starts working. And since the heater has a power rating and we need to figure out the amount of heat provided, amount of heat provided can be found out by the formula power times time. So here we will be using a stopwatch to measure the duration of time for which the heater is kept on so that we can find out the amount of energy that is supplied in the form of heat. Now, we know that the change of state is complete when the ice that is at 0 degrees Celsius has converted into water at 0 degrees Celsius and has flown down to the beaker. And at this exact point, we will stop supplying power to the heater. Take a note of the duration of time during which the power is or the energy is supplied to the heater. And using that, we can find out the energy that is input to ice. We also know that energy supplied and latent heat has a formula Q equals M times L. Since the mass of ice is known and the amount of heat is measured, we can use this to find the specific latent heat of ice. Moving on, in an experiment, 120 gram of ice, that is mass of 0.12 kilogram at 0 degrees Celsius is to be melted. The specific latent heat L is 340 joule. Since we're written in SI units, we'll convert to SI units. So this becomes 340 kilojoules per kilogram. Assume that all the energy from the heater is used to melt the ice. Calculate the expected time for which the 60-watt heater needs to be switched on. Here we have Q is equal to M times L. Q is, as mentioned here, power into time is equal to M into L. Power can be substituted as 60 watt. Time is an unknown. Mass is 0.12. Latent heat is 340 into 10 to the power of 3. Simplifying and making T the subject, you get the value of T to be equal to approximately 680 seconds.